So now in this video let's see some more sums based on the different types. Okay, so here we have one question in front of us, that is 0 to pi by 2 1 upon 3 sine square x plus 4 sine into cos plus cos square x. Okay, so as we know that whenever the sum it is based on sine square cos square, so what exactly we have to do? Again, this is one type was there in the integration. I guess it's a type number 6 for us. Whenever it is in the form of a plus minus b sine square x or a plus minus b cos square x or sin x or cos x are together. So how to tackle this sum? It is very simple, as I hope you all might be knowing the steps. The first step will be what you have to divide each term by cos square. After dividing, see to it that in the numerator you must have sec square and in the denominator tan square should be there. Suppose in case in the denominator if you see sec square, you will replace that sec square by 1 plus tan square. After that you will take let tan x equals to t, derivative with respect to x, tan derivative is sec square x. As here we took t, so as we know that in definite integral, whenever we take t for any sum, whenever we take let for any sum, the limit will get changed, and we know that in the last video lecture only we saw how to change the limit for the particular question. So remember one thing, whenever you take let for any definite integral sums, so their limit will get changed. Okay, so after replacing all the values, it will get the actual question, it will get converted into what? 1 upon quadratic form, and this 1 upon quadratic form is what? It is your type number 1a. Okay, so can you see that type number 1a is playing an important role for many sums, as it was playing an important role for integration chapter also, and here also it is playing an important role. So remember, type number 1, it is very important, as it plays an important role in many types. Okay, so now as per the rule, okay, so we have to divide each term by cos square. So we'll divide each term by cos square. So cos square x 3 sin square x upon cos square x upon 4 sin x into cos x upon cos square x plus cos square x upon cos square x. Yes or no? So here in the next step you will get what? 1 upon cos square x we can write as sec square x. 3 sin square upon cos square we can write as what? Tan square x. Here one cos will get cancelled, so sin upon cos is what? Tan, and this cos square will get cancelled, and here we'll get 1 into dx. So as per the rule, we have to divide each term by the cos square, and see to it that in the numerator we must have only sec square, and denominator we must have only tan square. If in case in denominator if you come across sin square, then you have to replace this sin square by using identity formula, that is sec square x equals to 1 plus tan square x. Okay, okay, so here clearly we can see that in the numerator here we have only sec square x, and in the denominator we have only tan square x. Okay, so here we can start with let tan x equals to t, so therefore sec square x into dx equals to what? Dt. Okay, as we took let for this sum, so of course the limit will change here. So if x equals to 0, then replace x by 0, so tan 0 is what? 0. So of course t will be equals to what? 0 only. Yes or no? If you replace x by pi by 2, then t will be equals to what? Pi by 2 means what? 90, tan 90. sorry, pi by 2 here. Okay, for this sum actually it is pi by 4 in the question. Okay, sorry, here I wrote pi by 2. So here we have pi by 4. So when x is pi by 4, so here pi by 4, so tan pi by 4 is 90, so tan 90 is 1. Tan, sorry, tan 45, tan 45 is what? 1, because tan pi by 4 is 1. Okay, so once again we'll see in the question. Actually it is from your exercise number 2.2. I guess it is the question number 2, second sum, second exercise, question number 2, in that sub question, that is second question. Okay, so there the value of integral is 0 to pi by 4, it is not pi by 2. Okay, change this. Okay, pi by 4. So now the first step, as clearly we can see that it look like the type number 6, I guess. Okay, so this look like 1 upon a plus b sine square cos square. Whenever you come across sine square cos square, so there is a format which you have to follow. The first step, dividing each term by cos square, then see to it that in the numerator it must contain only sec square, and in the denominator it should contain only tan. If in case in the denominator if you see sec square, you will replace the sec square x by 1 plus tan square. Then let, as we know that when we take let in definite integral, the limit will get changed. So here the first value is x equals to 0, then 10, then t will be equals to what? 0. Simply replace the value of x here by 0. So tan 0 is what? 0. So t is equals to 0. The next value is pi by 4 in the question. Okay, it is not pi by 2. So if x equals to pi by 4, so pi by 4 is 45, tan 45 is 1. So here we got the required limit for t, 0 to 1. Then in place of sec square into dx, we can write as what? Dt here. And in place of tan, we can write t. So this will be what? 3t square plus 4t plus 1. Okay. Okay, so as now it get converted into what? 1 upon quadratic. So we know that how to tackle 1 upon quadratic form. Okay. So I guess the remaining part you can try by yourself. As simply what you have to do, make the coefficient of x square, the square term, as here it is t square. So make the square term coefficient 1 and symbol should be positive. Already the symbol is positive. So in the next step, as 3, if you remove 3 from the denominator, it will come out with 1 by 3. Yes or no? So 1 upon t square plus 4 upon 3t plus 1 by 3 into dt. Rest, as the coefficient of square term is 1 and symbol is positive, so we can apply the third term formula. Okay, yes or no? I hope the rest part you can try by yourself. Okay, and apply the suitable formula. After that you have to replace the upper limit and lower limit to get the final answer. Okay, I guess you all understood this sum also. Let's check some few more example, few more sums based on some other types. Okay, so now here we have one sum in front of us, that is I equals to 2 to 3 x upon x square minus 1 into dx. Now first you have to guess the format, as here we have linear upon quadratic. Yes or no? And this look like, can I say that this look like f dash x upon f of x into dx, which we can write as log mod f of x plus c. Yes or no? As clearly we can see that here if we take the derivative for this part, derivative of x square minus 1, so here you will get what? 2x minus 1 will be 0. So simply we have to adjust, what we have to adjust 2, we have to multiply 2 to the x. So if you are multiplying 2 to the x, so see to that you have to adjust the number in a such a way that you must get the previous step. So here we will adjust this 2, will multiply and divide it by 2. So this 2 will get cancelled and you will get the previous step also. Yes or no? So now clearly we can see that this look like f of x and this is f dash x. So here f of x will take x square minus 1. So the important part is what here, the guessing. If you can't able to guess the type, so it will be difficult for you all to solve the sums. Okay, so for that only I am saying again and again, I will say, if you're perfect with your integration with all the types, all the concept, then only this chapter will become very easy, as hardly it contain 2 3 exercise. Okay, 70 to 80% of sums it is based on the integration only. Rest that 20% it is based on the definite integral property, and that also it is very very simple sums. Okay, no doubt, the sums are very easy compared to this, but you must know this integration also. Okay, so without knowing this, without guessing, you cannot able to solve the sum. So as here this look like f dash x upon f of x. Okay, just by practicing only you will come to know, you can able to guess the sums. Okay, so just practice the sums of integrations of all the types, at least take 3 3 4 4 sums based on the particular type, and tackle the sums. Try to solve two sums by seeing and two sums by without seeing, then only that confidence will come, and here in the definite integral you will able to guess the type for the particular question easily. Okay, so now f dash x will be what here, 2x, as clearly we can see that this is f of x and this is f dash x. So we know that integral f dash x upon f of x into dx is equals to what, log mod f of x plus c, yes or no? So therefore I equals to 1 upon 2 will keep as it is. Okay, so here the answer will be what, log mod f of x. What is there in place of f of x? X square minus 1, yes or no? As we can keep this 1 upon 2 outside the box. Okay, after integration, yeah, no need of writing plus c, as we are, the sums are with respect to definite integral. Here we'll write the limit upper and lower. After this, simply you have to replace the value of x first by 3. So 3 square is what, 9. First upper limit. Okay, 3 square is 9, 9 minus 1 is 8. Then minus by lower limit, 2 square is 4, 4 minus 1 is what, 3. So in the next step you will get half. Okay, so this look like what, this part, log a minus log b, which we can write as log a by b. Okay, so further this we can write as what, log 8 by 3, as this 8 by 3 we cannot cancel, so we can stop your answer. So the important thing is what, to guess the sum. Okay, so let's move on to the next sum. The next sum is what, in the numerator we have quadratic form, and in the denominator also we have quadratic. So as in the integration chapter I had explained, whenever we come across quadratic upon quadratic, okay, so you have to adjust the numerator in a such a way that you must get one denominator section same and separated by some other terms. Here I will explain what exactly we have to do. I equals to 0 to 1. Okay, so see, x square 1, x square plus 1 it is there. So can I break this minus 2 as plus 1 minus 3? So remember, whenever you come across quadratic upon quadratic, you have to break the quadratic, this numerator quadratic, in a such a way that you must get one denominator section, as here we are getting one denominator section and one other term. Okay, so now separate the denominator part. So here you will get x square plus 1 upon x square plus 1 minus 3 upon x square plus 1 into dx, yes or no? So 0 to 1, this will get cancelled, here you will get 1, yes or no? Minus 3 upon x square plus 1 into dx. I hope you all understood till here. Once again I will explain. Whenever you come across quadratic upon quadratic form, see to it that you have to adjust this quadratic in such a way that one part it should match with the denominator section, and one it can contain any other term. Okay, so after this here we have two separate terms, so we'll separate the integral part also. X square plus 1 into dx. Okay, so what is the integration of x? Can I write this 3 outside the integral as it is constant? So what is the integration of 1? That is x, yes or no? 1 and 0, no need of writing plus c. So 3, this look like what? Tan inverse formula, yes or no? Tan inverse formula, tan inverse x, because derivative of tan inverse is 1 upon 1 plus x square. So of course integration is the inverse process, so it will be tan inverse, yes or no? So 1 and 0. So now simply you have to replace the x by upper limit or lower limit. So here you will get 1 minus 0, 3 tan inverse 1 minus tan inverse 0. So 1 minus 0 is 1, minus 3 tan inverse 1 is what? Pi by 4. Tan inverse 0 is what? 0. So 1 minus 3 pi by 4 minus 0 will be pi by 4, yes or no? So therefore this we can add as minus 1 minus 3 pi by 4. Okay, in the last part just cross it. So here you will get 4 minus 3 pi by 4. I guess further we cannot able to solve our sum. So this is the final answer for this required integral. Okay, so remember, whenever you come across quadratic upon quadratic, you have to break this numerator quadratic in such a way that the first part you must get the denominator section, and second part you can have any other term. Then after that separate the integral, apply the suitable formula, replace the value of x by upper limit and lower limit, you will get your final answer. Okay, okay, so let's move on to the some few more sums. As here we have integral minus 4 to 2 1 upon x square plus 4x plus 13. Guess the type first. I hope you all let guess the type in your mind. Yes, it is your type number 1a. Okay, so what is the type number 1a? It is in the form of 1 upon quadratic, yes or no? So 1 upon quadratic, we know that first you have to make the coefficient of x square 1 and symbol should be positive, as already here the symbol is positive and the coefficient 1. Rest, apply the third term formula, apply the suitable integration formula, then you have to change the upper limit and the lower limit. Let it be here, if you have negative value it doesn't matter. Okay, here we have lower limit minus 4 and upper limit 2. Apply the suitable concept. Okay, suitable formula, guess the type. As I hope you all that guess the type in your mind, yes or no? So that was the type number 1a. Then solve it, substitute, replace the value of x by upper limit and lower limit, you will get your final answer. So please try this sum by yourself. So this one, integral 0 to 4 1 upon, again it look like what? 1 upon root quadratic, and we know that 1 upon root quadratic, again same third term method, but see to it that here the symbol of x square is negative. Already in the question if it says that the square term is negative, then you have to apply the third formula, which one? 1 upon root a square minus x square, yes or no? So here first make the coefficient of x square 1, already it is 1, then make the symbol of x square positive. So then next rest you can try by yourself this sum also. Okay, so this two sum take as homework. Okay, so we had guessed this sum as type number 1a, and this was type number 2a, yes or no? Got the point? Understood? Okay, so in the next lecture we're gonna do some few more sums based on some few more type, as in the next video lecture we're gonna see the sums based on integral u into v. Okay, as we'll take 2-3 example based on this sum, this type u into v, and then we'll see 2-3 example based on your partial fraction. I hope you all might be knowing what is partial fraction. It was your last exercise, last concept of your integration. So hardly we left with two more type, one based on integral u into v, and then one based on this type, which one, e raised to x f of x plus f dash x format, yes or no? So hardly we left with three types. One we can say integral u into v, one based on this property, and one based on partial fraction. So in the next video lecture we're gonna take 2 to 3 example based on this type. Okay, so hardly we left with last three type, and then as I told, the 70-80% sums based on the integration sums. Okay, so this was the sums based on the integration, and then after that we'll see the actual definite integral property. Okay, so actual definite integral property and its and the sums with respect to the property. Okay, so as there are almost 6 to 7 properties. Okay, so in that also not all the properties are important. There are 3-4 important properties, so we'll take that 3-4 important properties. I will explain the properties, and then we'll take 2 to 3 examples based on that particular property. Okay, so in short I can say hardly we left with the sums based on u into v type, sums based on e raised to f of x plus f dash x, and sums based on the partial fraction, and then sums based on the actual definite integral property. Okay, so the remaining part we'll see in the next video lecture. Till then, goodbye.